My name is R. Crosby Lyles, and this is News from the Can. Quick update. Yeah, there it is. Ain't going away. This band of CO2 at the 50 hectopascal level, which is around 60 some odd thousand feet. A cogent band of CO2 around the equator. It's about 1,000 parts per million. According to this, it's with that 1,000 right down here at the bottom. You see this legend, color legend. It goes up to 418 and then it jumps all the way up to 1,000. So, go figure. Anyway, it's not going away. Methane at the surface level. You can see that it's usual suspects. Interesting, California produces an ass pile of methane. Nothing compared, of course, to India and China, which has been probably the biggest producers of methane for 11,000 years, probably. Of course, swampy areas produce methane and so forth. But let's cruise right on through. Notable things. This is the total column of ozone, and this is the 50 hectopascal level, which matches up with. So this is 50 hectopascals, about around 60,000 feet. It varies from the equator to the poles. And you can see there's not as much ozone in the southern hemisphere as there is in the northern hemisphere. This is because of methane gas. And most of that methane is released from anthropogenic sources. Now, with the caveat of this is mostly covered with ice right about now. There's some water up here, but it's mostly ice. So we're going to have to assume that this methane is probably just sort of riding along the surface from other sources. I suppose it's possible it could be leaking up through the ice somewhere. And if we were to do some calculus on this, what's the actual, how much of this is, if this was, and some of it is from subsurface permafrost melting and so forth. But pretty much there it is. The Vice just put up a video. The guy is going around his business. He's got a business of capping abandoned oil wells in Montana, which there's millions of them. There's like millions of abandoned oil wells that are all seeping methane. But according to the Copernicus satellite, and this is the surface level, I'm not really seeing it. It might be some there that's cogent, but a lot of that methane's coming from fracking. Oil production, oil and gas production. You can see Russia and even Northern Europe, around Sweden, good old Sweden, and Europe, because they use methane for everything, power, energy production, and I saw somewhere recently that 3 billion people in the world prepare meals using open burning of wood fires, wood stoves. 3 billion people across the planet. So, okay, that's cool. Is it causing this? I'm going to do this step through and show you in a second. So this ozone here, and like I said, here's the 50 hectopascal level. Yeah, if you step through, let's just do that, shall we? Surface level ozone. Looks like that. You can see a lot of ozone over the surface of the ocean, which is, salt water. You get that. 850 hectopascals, I think, is about 1,200 feet up from the surface. And 500 hectopascals is 500 hectopascals is important because this is also where they measure geopotential height. And then let's see, 300 hectopascals, a little bit higher up. So a little bit more, right? And notice how it's more in the northern hemisphere. This is where the methane is coming from, or where the methane ends up, and then it works its way back. Okay, so this is ozone. Ozone comes from volatile organic compounds, the principal volatile organic compound being methane. So what you're seeing here is a footprint of methane. This is at 50 hectopascals, which is about 60,000 feet up in the air. And this is a hole in the ozone layer around this blue here is less. What is that? That deep blue there, it's this is in DU, which is Dobson units, 150 Dobson units, something like that, which just Google it. You know, that's the easiest thing, just Google it. Look it up on Wikipedia. But anyway, basically you're seeing that there's less ozone around the equator where there should be more. And that's because, which is this right here. Let me go back. All right. Total column, that's wicked, right? That's a wicked amount of. All right, what am I looking for? I'm looking for methane. So there's your methane at the surface. Methane at 50 hectopascals. Same band, right? There's your carbon, there's your methane. Carbon, methane, they're just in the same place because when methane breaks down, methane is a reaction body. It produces ozone. Ozone turns around, combines with reacts with the methane, and you get carbon dioxide and water. So this is releasing vast amounts of water vapor into the stratosphere at the same time. Look at this. That's like a little vortex there, which matches up with this. See that? This is, when you look at the geopotential height, what you're looking at is the blue is upper level low, the orange is upper level high, and basically like you're looking at like a golf course, hills and valleys. The blue is the pockets, the low areas, and the orange is the high areas. The air flows downhill towards this, and as it flows, because of Coriolis forces, it actually moves tangential to that direction. So if you draw a line from the high to the low, you'll see that there's a line that runs perpendicular, and that's where your jet streams are and so forth. Jet streams are all along these isobars. Okay. And you know, that's an aspect. This is something that I've seen before and exclaimed with much foul language, which I'm trying to curb. I don't know why. It's YouTube. It's supposed to be a platform that's fit for, you know, anybody over the age of 13, I think, or something. I always put PG-14 on stuff if I've got a lot of heavy foul language. But I guess, you know, what the hell? I'm not really in that mood right now. That's a lot of ozone right there. That's a fuck pile of ozone. Which is a greenhouse gas. Jump, you know, okay, greenhouse gas. Let's jump over here to the 2-meter temperature anomaly, which is measured between 1979 and 2000 baseline. 1979, year 1979, year 2000. That's your between those two. You know, that those 2 decades there that's their baseline that they're pulling from. It used to be a little bit a little bit different, and they changed it because of some reason. I don't remember exactly what. But anyway, this is climatereanalyzer.org from the Climate Change Institute, University of Maine. I always use this because it's a nice. I like their graphics. You can look at all this stuff. Links are in the description. See for yourself. But anyway, this is anomalously warm right here. And I'm kind of trying to make sense of that, but it really, I think, it just has more to do with airflow. You can see this 2-meter temperature, anomalously warm band going this way. Well, that's the direction of the air movement. When you look at this, this is your geopotential height, and the air moves along this line from west to east. You put your back to the wind, point to the left, that's the low pressure, right? So it's moving along this way, and that matches up with this line right here. It's just drawing warm air. It's just depositing warm air from the ocean up into the upper reaches of Canada, where you're going to find it, that's also humidified, and you're going to find more precipitation. However, having said that, another puzzle is that there doesn't seem to be that much precipitation there right now. You get some snow right here, but this kind of like a little, I don't know. This is clouds and precipitation, so it doesn't look like there's that much precipitation according to this. And look at Ventusky, Sky. See, it's kind of a void there. It's snowing a good bit over here, but a lot of times that anomalous temperature is from precipitation. It doesn't appear to be that way at this particular point, but there's your anomalous temperature, and there's your 50 hectopascal ozone and your total column ozone. So a lot of it has to do the anomalous temperature has to do with, I think, the airflow. But there is a lot of ozone there, and this is the point I really wanted to get to is they talk about polar amplification. And this is very important to point out that when you look at the carbon dioxide, right, this band of carbon dioxide is at 50 hectopascals. It's kind of high up, which may produce. There's some heating in the stratosphere, which I don't have at my fingertips at this particular point. I have to look it up. But as you go down to 300 hectopascals, right, you see that it coalesces. There's more towards, and I wish this fucking thing wouldn't jump around. Right, 300 hectopascals is a little bit lower down. I want to say it's like 30,000 feet ish, something like that. And 500 hectopascals is 15,000 feet, somewhere in there, something like that. Now you can see that there's, so this is at a lower level. This is at a lower altitude. There's more carbon dioxide closer to the surface. But as you get, so 850 hectopascals, about 1,100 feet, somewhere in there like that, it lightens up quite a bit because it's getting soaked up by the ocean and by plants. And here's the surface. The surface is much less. So one thing that I wasn't expecting to see personally, I was not ever expecting to see, and it was a surprise to me to see a cogent band of 1,000 part per million CO2 around the equator, which means that what we're seeing is, if you look at this, the 2-meter temperature anomaly, all the white there is nominal temperatures. That's nominal for 1979 to 2000, meaning it's unchanged. And the blue means that it's colder than, right along the equator. Up in the upper reaches where the carbon dioxide, methane is closer to the surface, it's warmer. So that's like the blanket. That's the blanket analogy. You know, when you're sleeping at night, you hold the blanket close to yourself to keep warm. If you hold it out away from yourself, then air can pass through, and the photons can leave and stuff, and you're actually colder. It's kind of similar, but it's really and it's a function of statistics, because when the greenhouse gases are further away in the stratosphere, then the photons, because they're going in any direction, uncertainty principle, well, more of them are likely to escape into space than to be directed back towards the Earth. Whereas if the greenhouse gas is closer to the Earth, then it's more likely to hit another because that's how the heat trapping works, is that the photon is captured by a greenhouse gas molecule, which ejects that, it emits at the same frequency that it absorbs, and then it trades back and forth between molecules, and that's how it traps the heat. So higher up, it's more likely to escape into space, and it causes global cooling. So the upshot is that because of where the blanket is positioned around the equator versus where it's positioned around the pole, particularly the North Pole, you're seeing anomalously warm temperatures around the North Pole and anomalously cool temperatures in the southern hemisphere and along the equator. That's going to play games necessarily with the polar vortex, which is really what you're looking at. That's the nice thing about looking at geopotential height. When you're looking at geopotential height, you're looking at the polar. Well, you look at this so you can readily see the polar vortex. And I'm going to look and see. Now you can, when you look at it from this global view here, you can really see it. It really pops out. You see this this spot right here is a spot where the pressure is a little bit higher at that 500 hectopascal level. The height. It's the height of 500 hectopascals is what you're looking at. So the blue, it dips down to 495 decameters, which is 4,950 meters. 4 kilometers, 4.95 kilometers. And the orange is 5.95 kilometers is the height of that pressure. And that's how that allows you to see the landscape, the air bubbles, so to speak, which allows you to see what the polar vortex looks like. And when you have extreme temperatures, what happens is the whole global warming spiel is that what you really end up with is the temperature of the Earth equalizes, where the equator actually cools down and the poles heat up. And when that happens, the polar vortex kind of goes crazy. It's less stable, it's less tightly bound. And then so that's when you get this stream of air that runs along the boundary between the upper level high and the upper level low. It allows cold air to be brought further south and warm air to be brought further north. So that's the spiel. But the other wrinkle is this blue pole right here. And I started noticing this a few weeks ago, because it was actually this kind of like this heated up for a little while. I'm thinking, well, maybe that's a good sign. But now it's like cooling back off, and we see that there's some anomalous temperatures at the anomalous 2 meter temperatures around Spain, and they're like having snow and stuff in Madrid, right? And and some folks are kind of waiting for that, thermodynamic fluid systems currents can change on a dime. They can just snap from one regime to another, which is what people are worried about with the Gulf Stream and the North Atlantic Current, and the AMOC, the Meridional Overturning Current, which runs up and brings warm water up into the North Atlantic. And when you see a blue hole right there, right adjacent between Greenland and the British Isles, between Greenland and Europe, that's an indicator that that's where the meridional, the meridional overturning current is supposed to dive down and give up its heat. So that's an indicator that maybe it's shutting down. And when it does, and this water here turns colder, then you don't have this rising, as much of this rising heat. And because Greenland is basically a big fin, a 9,000 foot fin, or dune, if you will, of snow, a snow bank that's 9,000 feet tall, right? And it acts like a weather vane in a sense. So that cold air can just come right across from the North Pole right down to Europe without being blocked by the warmer temperatures. And just take a look at the actual. It's also very instructive, you know, when you see these bright colors, it's like, oh my God, you know, but don't do that. You got to look at the actual temperature. That's just telling you what the departure is of the temperature. You always want to look at the actual temperature. And when you do that, you can also handily see the currents. And you can see some of these temperatures right offshore where there's upwelling are pretty low right now. So it just means that, you know, some freaky changes could happen, and how long or short term that is, it's really hard to say. But when you have an ocean current that changes direction, and also bear in mind that when you're talking about ocean currents, you're talking about because of the nature of laminar flow, that's like curlicues, it's eddies, that when it flows because of friction, it wants to curl around. So it's really this tapestry of like curlicues that goes out across the ocean. It's not necessarily a cogent river necessarily, but where you have areas where there's a differential in temperature, it appears as though you'll see like these river-like looking things. Something that's a cogent sort of flow. Something that I saw here, it was a red flag. It was a few days ago, right between Spain and France. This little spot here, and off the tip of my tongue, I couldn't tell you what exactly the region was, but the water temperature there was much below. Outflow from river, I saw that. It seemed to be a little bit bigger, and I was like, And I'm looking at these temperatures here, and I'm like, because that's the storyline from the day after tomorrow, which is a legitimate. This is what the U.S. military was operating on. That was that was their. That was the tagline for a long time. That's what they were expecting. For a sudden shift in the AMOC, and then for Europe and other places to be plunged into a new glacial period, which we're in an ice age. We've been in an ice age this is like a technical point. People get hung up on. But we're in an ice age. We've been in an ice age for about 2-3 million years, somewhere in there. And the spikes that we see in our global temperature are between glacial periods and interglacial periods. So we've been in an interglacial period, and each glacial period follows a spike in global warming. The temperature of the Earth goes way up, and then it drops. It just peaks. There's a sharp turnaround. It doesn't peter off like this. It goes way up and then it drops. And my theory is that at the top of that, and whatever causes that, whether it's a sharp temperature change or whether it's fires, there's a lot of fires. Firestorms. This is something that they talk about, like in nuclear war. Fears of nuclear war is that firestorms would cause so much material to be ejected into the upper stratosphere that it would cause global cooling and plunge us into a nuclear winter. Well, Remember all the fires that have been in California and Alaska and Sweden and I think maybe up here in North Europe, Northwest Europe, and Siberia, big giant fires. Does that qualify as a firestorm? And what did that do? And how much material did that throw into the air? Well, not only that, but we've had things that have looked pretty much like a methane pulse also. So carbon dioxide goes up, you have more heat, you have more fires, more carbon dioxide is produced. So that produces your global warming spike, and then somewhere along the line there's a shelf of methane that gets dislodged, and you have a methane pulse. That methane pulse ejects a whole bunch of water vapor and carbon dioxide into the stratosphere. You get that band of carbon dioxide that we see right here. I mean, there it is. You know what I mean? There it is. And now they're talking to the farmers, and they're having these issues with farmers in India, probably because they're trying to get them to curb their farming practices, which is pissing in the wind anyway, because this shit here is from fracking. Straight up, bottom line, it's from fracking. It's just, painfully obvious. So, and we might have had a methane pulse as well. Back in 2012, the Pacific Blob anomaly, Google it, was probably caused from, they had large amounts of ozone that were wafting off of the Pacific Blob anomaly, which is over here right off the Pacific Northwest, right? Well, that's probably from methane. I've done many videos on that already. So there it is. And, it might be like kind of sort of, it's as wicked as it looks. It might be, it might be a period of sort of like business as usual. But we did have an ass pile of storms this past year, like broke a whole bunch of records. They were into the Greek names already. They ran out of names like a long time ago. We broke some records with landfalls of storms and storms produced, but right now it's kind of quiet. That's why I like to look at Ventus Sky here. If you look at that and you look at the air pressure, and it'll tell you anyway. They'll show you where the tropical cyclones are, and I don't see any. There's some little. These green areas are areas of 29.6 inches of mercury. That's pretty low right there. Okay. So, but it looks pretty quiet out there with that 28.6 inches of mercury. 28.7 right off the tip of Greenland there. Here's your precipitation. I also like to look at the freeze line. And this is a height also. This tells you in feet. So wherever it's gray, it's at the ground level. And anything above that, the blue is 600 feet. This blue here, I think, is 1,200 feet. The red, it gets to be 7,000 feet, I think. Oh, here we go. 9,500 feet. So, London over here, 8,300 feet. Huh. Wow. So the freeze level is not down to the surface, all the way up here to Greenland, which is fascinating, But there it is, and there's your precipitation. They've had a lot of rain in Brazil and Ecuador, Peru, Bolivia, somewhere in there. They had a lot of rain. Well, you can see right there's a lot of rain there, but flooding and stuff like that, pretty serious. And they had heavy snow in Madrid. So I got to look and see if make sure that's not old shit I'm looking at, because you know how that goes. I see shit in my feed, and it's like, you always got to check and make sure you're not looking at some bullshit that somebody uploaded from last year to try to make you think that it's going on now, just to get clicks and views and stuff. Storm Filomena, alert, Spain. Okay. This was 1 day ago, New York Times. Okay, there you go. There it is. Fox, 1 day ago. Spain is still digging itself out from Filomena. It's the worst snowstorm in 50 years. It's a lot of snow. So, this is stuff that I'm looking for. And if the paradigm shifts, it may stay that way for a good little while. And this is just what I'm looking for. And with as much crap as we're pumping into the atmosphere, as much methane is being released and stuff like that, it's really kind of hard to say how the deal's going to go down. But we did have a lot of storms. We've had a lot of precipitation. And when you start seeing 5-6 feet of rain, in a very short amount of time, like we did with hurricanes past in Texas and, South Carolina, North Carolina, Georgia, there's some areas in Florida, 2 areas in Florida, Daytona, and some areas in the Panhandle that have seen, over the past 10 years, have seen a foot of rain drop in an hour and just get totally flooded out. It happened in Live Oak. Live Oak was completely flooded, I want to say, about 9 years ago, something like that, completely flooded out. It was flooded for, I want to say, like maybe a week or two, and then a sinkhole opened up, drained the whole town in one day. It's not funny. It's just terrible. Temperature and water is a compressible. The thing about water vapor, water is a compressible substance. So when you heat it up, it expands, and when you cool it down, it contracts all the way down to a liquid. And this is what causes expansions and contractions and air movement in the atmosphere. Volatility, energy. There's so much energy in the atmosphere, and it by and large is from water vapor. That's what we got a lot of, because it's a water planet. And that's about it. Love you guys. Thanks for watching. I'm trying to stay out of politics, but in a way, it's like, I don't know. It's pretty obvious what's going on, and I don't really want to comment about it right now. Not on this fin. I do that on Facebook. I do all my politics over on Facebook. I kind of leave it off the YouTube because I want to stay focused on science. I got some theoretical shit I'm working on. I'm supposed to be working on gravity, on anti-gravity. That's been my thing for over 20 years, 25 years. So that's what my actual thing is. This is sort of like something that I stumbled on, and I'm like, holy shit. This needs to be talked about, because nobody's talking about it. Nobody's talking about it. This thing right here, radio silence. And I'm like, holy shit. That's going to be a problem. That's different. And it's a cogent band, and it ain't going nowhere. Where's it going to go? It's in the stratosphere. You know what I mean? My thought is because it's because CO2 is a somewhat heavier, has a molecular mass that is somewhat heavy in comparison to other molecules, that it would just rain out somehow or other, or that it would, CO2 really likes water. It just absorbs into water. So it comes out in the rain. That's why you don't see it very much in the lower atmosphere. So it'll be interesting to see, and that's a lot of discussion. You got to go to, I wish they made better videos, and I wish that NCAR made better videos, and I wish that they did not, that they had their comments, that they left their comments open, and just get like a postdoc or somebody to go and police your, just answer questions, and you know what I mean? Educate people. It's a conversation. If you don't have comments, it's like people are just not going to engage with you. So you want engagement. So don't turn your comments off. Leave your comments up. Leave your ratings up. I mean, it's, maybe that's a judgment call. I don't know about the ratings thing, but who cares? Who gives who gives a shit? You know what I'm saying? You're trying to educate the public. This shit's going on. Somebody with a brain, somebody like Richard Lindzen, is going to need to explain this. And others. So there it is. you know, and to validate this imagery here, you know, that's a whole other thing. I got to call in people and talk about it. And anyway, that's it. I love you guys. Thanks for watching. You know, stay tuned, and you know, get a ham radio. They're cheap. You get a little handheld ham radio, shortwave ham radio, so you can, in case the shit hits the fan, you got a means of being able to communicate, find out what's going on. That's, you know, and you know, have supplies, provisions. You know, the Patriot people sell these buckets of provisions and shit, and, you know, keep yourself some dried beans and stuff like that, and way to create power, and just watch what's going on, because we're beyond the politics. You know, one of the things about politics is we're sort of like beyond politics now, because we're like in this sort of shit hits the fan area. Pandemic, this CO2 thing, you know, which might be related in ways, and so wear a mask, wear your PPE, you know, do what you got to do, and that's it. Thanks for watching. See you.